Okay, so I'm going over Module 11.1, and I'm going over Explain 1, and I am on page 535. So Explain 1 goes over translating between radical expressions and rational exponents. So going from a rational exponent to radical form, or going from radical form to rational exponent. So it says, in the Explorer, you found that a rational exponent of m over n with m equal to 1 represents the nth root, or that a to the 1 over nth power equals the nth root of a for positive values of a. So this is also true for negative values of a when the index is odd. So when m does not equal 1. You can think of the numerator m as a power and the denominator n as the root. The following ways express the exponent m over n are equivalent. So what that's basically saying is, well, you'll kind of see it here too, but how can we, if we have the nth root of x, we know that that's x to the 1/nth, but what happens if it's not an exponent of 1 here, basically is what we're going to be looking at. So rational exponents. For any natural number n, integer m, and a real number a, the nth root of a is real. So the exponent m over n indicates the mth power of the nth root of a quantity. So what this looks like is if I had 27 to the power of 2/3, so 27 to the power of 2/3, the 3 is the index of my radical because that's the third root, or the third root basically of 27. And then the 2 right here is actually the exponent on the outside, or the exponent inside on the 27. So the way that we kind of think about this is, what is the third root of 27? And the third root of 27 is 3 times 3 times 3. So the third root of 27 is 3. And so if we replace this value right here with a 3, we get 3 squared. Okay? And 3 squared is equal to 9. So the general way of thinking about this is that the denominator is your index, and the numerator is your exponent on the outside. Okay, and now looking at the second part here, it says an exponent m over n indicates the nth root of the mth power of a quantity. So rather than taking that numerator and putting it on the outside, you can put it in the inside as well. So here we have an index of 2, which is why there's nothing written here, because we know the square root has a 2 there, so we don't have to write it. And then that numerator 3 can go on the inside, or it can go on the outside, which is basically what this is teaching you. If you put it on the inside, look, you have 4 to the third power, which is 64, because 4 times 4 times 4 is 64. And then the square root of 64 is 8. So now looking at it in the general term, n, again, is still always your index. Notice how that's the case in both of these. N is the index, okay? And then in this case, m, rather than putting it on the outside of this whole expression, we can go ahead and put it on the inside right here. So you can rewrite either way. So example 1 says to translate the radical expression into expressions of rational exponents and vice versa. So simplify numerical expressions when possible and assume all variables are positive. So for a, if we're looking at this and we want to rewrite it, we're going to remember that the bottom is always my index, so that's why we have the cube root here. And then this 4 can either go on the outside or on the inside, and in this case they decided to put it on the outside because negative 125 to the 4th power would be a really, really big number. And so in this case it actually made sense to put it on the outside. The cube root of 125, or negative 125, is negative 5. And then negative 5 to the 4th power is 625. So I'm going to do that question without using the guided notes, just to show you how I would have done this. Whoops, sorry, it's a 3 on the bottom, not 5. So I would have immediately drawn my radical and I would have said, hey, I know the denominator is going to be my index, so I write that there. And then I decide if I want to put that exponent in the inside or the exponent on the outside. And I look at what my radicand is. Well, my radicand is going to be this. And like I said, or negative 125 to the 4th power would be really big. So I'm going to decide to put it on the outside first. Okay, and from here, the cube root of negative 125 is negative 5. Sorry, So I have negative 5. This expression right here equals negative 5. And then I have to the 4th power. And negative 5 to the 4th power is 625. Okay. Here, if we're looking at part B, the denominator is my index. And so I put my index there. The exponent, or the numerator, can either be the exponent inside or the exponent outside. And notice that they wrote both ways here. It could be this or it could be that. Same thing for this one here. If we're rewriting it, remember your index is your denominator and the power or the exponent is the numerator. And then for this one here, index is my denominator and my exponent is my numerator. So we're just rewriting these right now. So let's look at part B where we actually have to do it ourselves. So for A, let's go ahead and first look at what our index is going to be. Our index, this number right here, is a 4. And the exponent on the outside is going to be the numerator, which is 3. So the 4th root of 81 is 3, and the 4th root of 16 is 2. And the way that I knew that was 81 is 9 times 9, and 9 times 9 is 9 is 3 times 3, and 9 is 3 times 3. So when you're looking for the 4th root, you're looking for what repeats 4 times, and that was a 3. Like 16 is 4 times 4, which is 2 times 2 times 2. And so 2 repeated 4 times, that's why the 4th root of 16 is 2. And now if I cube 3, I would get 27. And if I cube 2, I would get 8. So my answer here is 27 over 8. Part B, denominator is always your index. And then that power, that numerator, can either go on the inside. And notice that they have these in parentheses here, right? That power goes to both the x and the y. Or the other way we could have written this, your index is 3, and your power goes on the outside of this. And either way is correct. So let's do this one. My index is my denominator, and my power is my numerator. And if we simplify this, 6 over 3, well, isn't that just 2? 6 divided by 3 is 2, and so 11 squared is 121. And then for part D here, my index, remember, is your denominator, and my power is my numerator. So I get 2, or the quantity of 2x divided by y, all to the power of 5/3. I hope that made sense. Let me just give you one little example here. Let's say I have, kind of a recap here. Let's say I have x to the 4th power, and I'm taking the cube root of that. I can rewrite that as my denominator of my power is going to be my index. So the denominator is going to be a 3, and the power is going to be the numerator. And so we could say the 3rd root of x to the 4th is, or sorry, the cube root of x to the 4th is x to the power of 4/3. And vice versa. Let's say I had x to the power of 2/5. I could rewrite that with 5 as my index, And then the 2 can either go in here, or if I had this set up, there we go, or remember the 2 can go on the outside. Either one, it could go here or it could go there.